Many of you have a good idea what engineering and computer science are, but let me just briefly say that engineering has a foundation of math, physics, and chemistry. It's based on science. The thing that sets engineering apart is that it adds creativity. I like this quote by Theodore von Karman, who was a very famous aerospace engineer. Scientists discovered the world that exists. Engineers create the world that never was. All that we do in engineering and computer science is aimed at helping improve the quality of life for people. We build the tools for scientific exploration. We develop communication technologies, build the infrastructure that supports life. We are the ones who really make an impact on improving the environment, and we're even very involved in entertainment. We also are focused on energy availability and efficiency. Huge progress has been made in these areas. The increase in productivity over the past 30 or 40 years is largely based on the computerization and automation of manufacturing and production, which is all the result of engineering and computer science. Engineering is very involved in improving safety and even healthcare. There's a huge connection between engineering and medicine. This is a list of the departments and programs that we have in engineering at the University of Utah. The words in red are departments, and each of these have bachelor's, master's, and PhD degrees available. So we have biomedical engineering, civil and environmental engineering. The units that are listed in gray are degrees that are available that are taught by these other departments. So nuclear engineering and construction engineering are part of civil and environmental engineering. Chemical engineering also has a master's degree in petroleum engineering, mechanical engineering, electrical engineering. We have a computer engineering degree that is jointly taught by electrical and computer engineering in the School of Computing. The School of Computing also has a degree in data science, and we have a program in entertainment arts and engineering at the bachelor's and master's level. Material science and engineering is a department that is joint between the College of Engineering and the College of Mines and Earth Science. And the College of Mines and Earth Science also offers degrees in metallurgical engineering. That one's within material science and engineering. And they have mining engineering and geological engineering. You'll see that there are some breakout sessions in those areas where they can give you more information. We don't have time to go into each of these in great detail, but I'm going to give you a quick overview of some of these degrees and what people with degrees in these areas might do in their careers. Starting with biomedical engineering, we have one of the oldest biomedical engineering departments in the country. People in that area might work in biomedical implants, biomedical sensors, artificial organs and limbs, tissue engineering. And there's a very exciting project going on in our biomedical engineering department now that is managed by Professor Jan Kubanek, who's using ultrasound to treat depression. In chemical engineering is kind of a combination of chemistry and engineering. People in those areas work in sustainable energy, We have people very focused on air quality and the environment. They work on wet materials and nanotechnology. We have people focused on biotechnology and medicine. Smart chemical processes, I mentioned they have a petroleum engineering degree, and multi-scale computational simulation. One of the things you'll note in engineering is that the lines between departments are not rigid. So this last point is an example of a very close connection between chemical engineering and computer science. In civil and environmental engineering, we have faculty focused on many aspects of the environment, including clean water, water quality in general. There's a geotechnical area focused on the appropriateness of soils and so on to build structures on. Structural engineering, we have a big activity in transportation, and we have a separate degree, as I mentioned, in construction engineering. Electrical and computer engineering is part of a spectrum of disciplines that I'll mention. This one is the closest to physics. So ECE has activity in computer and microprocessor design, Microelectromechanical Systems, which is basically building little micro sensors and machines using semiconductor processes. A lot of electrical engineers are focused on communications and electromagnetics, basically building cell phones and the technologies related to those. They do image and signal processing, much of that in the medical space. We have people focused on optics, semiconductors, the controls side of robotics, and power systems and controls. Moving from electrical and computer engineering to the degree computer engineering, again, I mentioned that this is jointly managed by ECE and the School of Computing. People in computer engineering use electrical engineering and computer science ideas to focus on computers. So they design digital circuits such as microprocessors. They do computer architecture, build computer networks and systems, and they do the software that's closest to the hardware. This is a challenging degree because people have to be competent both in circuits and software. Moving on to computer science, as you're aware, this is more the programming or software end of the spectrum. So most people in computer science are very competent in writing computer programs. They do a variety of computer applications. The University of Utah is very well known for its seminal work in developing computer graphics. They focus on databases, human-computer interfaces, data science and analytics, which is a very hot topic these days, artificial intelligence and machine learning, which is getting a lot of attention, and cybersecurity. As you know, as we become more and more dependent on computers and computer networks, security has become critically important. Computer science is also very involved in robotics. We have a strong robotics area here at the University of Utah, and it involves computer science, mechanical engineering, and electrical engineering, and to some extent other departments. There is also an entertainment, arts, and engineering track in computer science. And so I'll mention that we have an entertainment arts and engineering program, and this is a highly ranked program. It's basically developing games, computer games, and as you can see in the numbers here, we've been ranked in the top 10 in the world in our undergraduate degree and also in our master's degree. There are many applications for games. In addition to entertainment, we have people who build games to help with education and even in health. The University of Utah also has an esports team that competes nationally and has done very well. I should say that there is a games degree offered in the EAE program, but you can also get the EAE experience and get a computer science degree. And if you do that, your job opportunities are broader because you can do anything that a person with a computer science degree can do, but you can also work in the games industry if you choose to. Material science and engineering is focused on nanotechnology, batteries, fuel cells, basically materials for every application. They make electronic materials, biomedical materials, and now with the merger of this program with the College of Mines, they also have the metallurgical engineering degree. Mechanical engineering, as most people would know, is focused on building machines, their design, development, and manufacture. As I mentioned, robotics is big in that program. We have a great program making artificial limbs and an exciting program that does drones. If you're interested in aerospace engineering, mechanical is the place to be. And one of the biggest areas in aerospace these days is composite materials, and we're very strong in that area. Also, fluidics, including microfluidics, is in mechanical engineering. Mechanical engineering is also involved in the MEMS area, Microelectromechanical Systems. The image you see in the lower center is a micro machine. I don't know the exact size of that, but you could probably fit hundreds of them on the head of a pin. We have a nuclear engineering program, which I mentioned is housed in civil engineering. You may not know we have a nuclear reactor on our campus. It's in the Merrill Engineering Building. It's one of only 13 reactors of that type at universities. And nuclear engineers are focused not only on nuclear power plant design and operation, but also medical applications, nuclear forensics, industrial testing, food safety, and many other applications. We have a minor at the undergraduate level, and then we have master's and PhD degrees at the graduate level. There is so much demand for engineers that companies actually run ads on television to try and attract people into engineering. You know, everybody talks about STEM, science, technology, engineering, and math, but the jobs are all in the E part of STEM. Here's an example of one of those ads.
Want to change the world? Create things that help people. Design safer cars.
Faster computers, smarter grids, and smarter phones. Think of new ways to produce energy.
Be an engineer. Solve problems the world needs solved.
What are you waiting for?
Changing the world? Part of the job description.
Join the scientists and engineers of ExxonMobil in inspiring America's future engineers. Energy lives here.
Now, the engineering degrees are challenging. You work harder in engineering than you would in any other discipline. But there are financial rewards as well as job satisfaction when you get graduated. This is data that I took from the National Association of Colleges and Employers. They do surveys of BS graduates' starting salaries. And as you scan across this, you can see the difference in starting salaries for various areas. So there's obviously a spread of salaries. The top darker dot in each of these ranges is the 75th percentile. The dot in the middle is the median salary, and the lower dot is the 25th percentile salary. So salaries actually go beyond this range, but you can see that engineering and computer science have the highest salaries of any of these areas that are shown in this chart. And if you break that down into just the engineering and computer science degrees, you can see that they're all very well compensated. There's a little bit of difference as you go across this. And again, these are just starting salaries, excuse me, for new graduates with BS degrees. If you get master's degrees or PhD degrees, obviously the salaries are quite a bit higher than these. But these are all great starting salaries, and there is demand in all of these fields. So I hope all of you are at this point thinking about the benefits of being in engineering or computer science. I'd like to spend a few minutes now talking about reasons you may want to choose the University of Utah to get your degree. The U is the flagship state university in Utah. We have about 32,500 students, 15 colleges with all of the big major colleges represented. The university was founded in 1850, and engineering started being taught here in 1891. We're part of the Pac-12 athletics, but also academics group. And I can tell you that having the Pac-12 schools as our peers in engineering puts us in very good company. The university as a whole had over $600 million of sponsored research awards this past year. The Carnegie organization classifies universities into different groups. The University of Utah is a research university at the very high research level. We are the only one in the state of Utah in that category. And just about a year ago, the University of Utah was invited to become a member of the American Association of Universities. This is the 65 universities that have the strongest research programs in the country. There have only been a few universities invited into this group in the past decade. And if universities aren't performing in research, they're removed from the group. So as I mentioned, we're in the Pac-12. There's some very strong universities in terms of research in this group in engineering. This is a picture of the website. We host the website for the Pac-12 engineering deans, and this group of deans gets together multiple times a year to talk about issues of common interest among the universities. So in this group, there are some things that are unique about the University of Utah. The Wall Street Journal published a list of the best value universities out of more than 2,000 universities in North America. And the University of Utah was listed as 11th in the best value. Value involves the costs compared to the benefits of having the degree. Degrees from different universities have a different value to you. And the University of Utah has a very high value degree, and the costs are very reasonable. If you come here, we'll help you make the very most of your abilities. There was an article published in Reuters last year that talked about the difference in values of degrees at different universities. And it claimed that if you get a degree from a selective college, one that you have to have good credentials to get admitted to, your degree would be worth 20% more. And they pointed out that in engineering, that difference is even greater. So a degree from the University of Utah will enable you to work at any company and to attend any graduate school. You can get degrees that have the same name from some other universities, but many companies won't even interview you. We hear this often from members of our industrial advisory group who say there are just a few universities that they want to interview at, and the University of Utah is always at the top of the list. In terms of tuition, this chart shows for the Pac-12 schools the in-state tuition and out-of-state tuition. And you can see that of all of the Pac-12 schools, the University of Utah has the most reasonable tuition. There are some things that, if you were thinking about going to a research university or a university that's more focused on teaching, there are some advantages to getting your degree from a research university. First of all, we have the leading edge faculty. They're the ones who all have PhD degrees. They are the ones who are actively involved in pushing the frontier of their specific area. And they're the people who will be teaching you in your classes. Because it's a research university, there are seminars going on all the time with people from other universities or faculty or graduate students. And these are all open to the public. So you're able to take in all of these seminars. You're rubbing shoulders with graduate students. We have the best equipped laboratories. Every student will have a signature experience. For many of you, it will be your senior capstone project where you'll do a realistic engineering or computer science project. And many students are able to get involved in research while they're still undergraduates, to work in a professor's research lab, again, rubbing shoulders with PhD students. We have a rich curriculum. If you're comparing different schools, you need to look at the size of the faculty. We have about 220 faculty in engineering here, and we teach, last time I checked, 684 courses per year. So each discipline has a breadth and richness in their curriculum. It's not just a minimal curriculum that we offer. Research expenditures in engineering have gone up consistently over the past 15, 16 years. We have seen a great growth in the research activity on campus. And in fact, the University of Utah's reputation in engineering has improved significantly through this period of time. We have beautiful new facilities. This is just one of them, the Sorensen U-Star building that was funded mostly by the state of Utah. And it includes a nanofabrication laboratory that is state-of-the-art, filled with very expensive and interesting equipment that students get to use and learn how to use. This particular instrument, the GEM 2800, is a scanning tunneling electron microscope. It costs several $1,000,000. The image in the upper left shows you some material that it took this image with, and those little bumps are individual atoms. So there's a lot of this kind of equipment, both in this laboratory and throughout the college, that you will be able to learn how to use and use to help get your education. I mentioned the senior capstone projects. This is an example of one of the department's exhibition of the senior projects. The mechanical engineering department has what they call Design Day. This is in the student union. They fill it with the projects done by their senior students, and it's a very exciting experience. All of the departments have something like that. Here's an image that shows, this is a chart actually comparing the University of Utah to other Utah system of higher education schools. On the x-axis is percentage of graduates who have debt when they leave the program. And on the y-axis is the graduation rate. So you want to have a high graduation rate, and you want to have a low student debt rate. And you can see that the University of Utah stands off by itself with what is now higher than a 70% graduation rate and relatively low student debt. If you graduate from the University of Utah, you will join some very notable alumni. I'll show just a few here. Cy Ramo was the R in TRW. That was the company that built the intercontinental ballistic missile system for the United States back in the 60s. John Warnock is the founder of Adobe software. You all use Adobe tools every day. John developed PDF. Alan Ashton developed WordPerfect. Ed Catmull is the founder and was president of Pixar. Mark Fuller founded WET Technologies. If you've ever seen the Bellagio fountains in Las Vegas, that was one of their first signature projects. Jim Clark developed the first commercial internet browser, Netscape, and founded a company called Silicon Graphics. There have been many other companies founded by University of Utah graduates. You may wish to live on campus if you come to the U. We have some very interesting student housing. This is the Lassonde Entrepreneur Dormitory. It has 400 beds, and students who live here are students who are interested in entrepreneurship, which is another thing that sets the University of Utah apart, as I'll mention in a few minutes. But there are many excellent opportunities for living on campus. We have a lot of student housing that started out as athlete housing for the Olympics. And it's some of the best student housing I've seen. There are a number of other programs you might want to get involved in as a student here. And I'll mention just a few of these. We have international exchange programs with some of the top colleges of engineering in the world. You can see we have them in a number of different countries. We have them in universities where the teaching language is English, and where you could use other language skills to study for a semester. And we help students to make sure that the credits that they get while they're studying abroad will directly apply to their degrees here. The University of Utah was one of the earliest adopters of what's called the Grand Challenges Scholar Program. This is something that was established by the National Academy of Engineering, and it allows students to get a designation on their diploma that they are a Grand Challenges Scholar graduate. And that means quite a bit to other schools where you might be applying for graduate studies. These are the grand challenges that the National Academy identified, and getting this designation means that you have to do a little extra work in several areas. One is international, another is entrepreneurship. There are several others, but you might want to look into that. It's a really valuable thing for you to do, especially if you're thinking of going to graduate school. I mentioned that the U is well known in entrepreneurship. There was a report that was done a couple of years ago by the Milken Institute, where they compared all of the universities in North America in terms of how many patents were issued, how many licenses were written to their patented technology, their licensing income, and the number of startups that were founded. And they concluded that the University of Utah was ranked #1 out of all of the universities. I like this quote that was in their report. The University of Utah has quietly evolved into one of the most prestigious research universities in the United States, with a strong emphasis on commercializing its research. The College of Engineering has spun out 84 companies since the year 2006. And I mentioned also that many of our alumni have also founded very well-known companies. If you're a student who thinks you might be interested in being an entrepreneur or being involved in business, here's some information that might be interesting to you. A survey was done of the S&P 500 chief executive officers. These are the 500 biggest companies in the United States. And remarkably, it was found that 1/3 of them have engineering undergraduate degrees. Only 11% of them have business administration degrees. And these quotes tell you why that's the case. Engineering skills include analytical thinking and problem solving, which are essential for being in a leadership position. This is taken from an article that described these percentages. Engineers who can combine their analytical and critical thinking skills with strong communication ability can be a powerful asset when it comes to top-level decision-making. In the College of Engineering, we have a program called CLEAR, where we make sure that the students develop very strong communication skills. We continue to hear from our industrial advisory boards that communication ability is critical to the success of engineers and computer scientists. So we have started an engineering entrepreneurship certificate some years ago. And this is another thing that you can get in parallel with getting your undergraduate or graduate engineering degree. You can take most of these courses as technical electives to your regular degree requirements. We make sure that you have some business background. This is done in conjunction with the business school. They developed a course specifically for this program that gives you the background that we think you need so that you can understand the way people in business look at companies. We also, as I mentioned, make sure that your communication skills are good. We have you take a course taught in engineering that gives you a background on patent law and strategy. And then when you do your capstone project, you do a little more work than the other students do. But if you get this engineering entrepreneurship certificate, you will be well equipped to be involved in founding a new venture. And even if you end up working for a large established company, your understanding of intellectual property and business concepts will be a great asset to you. We've had a number of students that have started companies. I'll show you briefly just one of those. David Toledo and Paul Slusser started a company called Power Practical. They were students in material science and engineering, and they developed this technology that would allow someone to use the heat in a cooking vessel to generate electricity to charge a cell phone, for example. They appeared on the TV program Shark Tank and were given $250,000 by Mark Cuban. They raised another $1 million in venture funding, and they ended up with a number of products that you may have seen sold in outdoor stores and even places like Costco and Walmart. But this entrepreneurial spirit is very much alive at the University of Utah. You can also apply for the honors program at the university. It turns out that there are more engineering students in the honors program than there are students from any other college. The honors program is very compatible with the entrepreneurship certificate or the Global Challenges Scholars Program. The number of graduates coming out of the College of Engineering has been growing very substantially. We actually took a slight dip this past year, and that is related to COVID. You'll notice the largest reduction was in PhD students who weren't able to finish up all of the requirements and have their defenses because we couldn't meet in person last spring and we weren't able to be in the laboratories for several months. But those students are still in the system, and we'll actually continue to grow the number of graduates. A leading indicator of that is this chart that shows the number of undergraduate students enrolled in each of the different colleges. The only one I've labeled is engineering, the red line, and you can see that it continues to grow. In terms of the number of students coming into engineering, this shows in the brown colored bars the number of students that have declared that they're coming into engineering, and in the red dots, the percentage of the freshman class that's coming into engineering. So back in 2005, 7% of the used freshman class was coming into engineering. In 2019, it was 23%. They haven't updated the dashboard yet that I get this information from, but based on the preliminary information I have, it looks like this fall, maybe 27% of the freshman class was coming into the College of Engineering. So the U is becoming very much an engineering school. This has all happened concurrently with a change in Utah's economy. Back in the year 2000, the state of Utah had 1,500 high-tech companies. It now has over 6,700 high-tech companies. Utah has the fastest growing tech sector in the country. And we've had a number of companies that have grown up in Utah and gone public or been sold for more than $1 billion. Those kind of companies are known as unicorns. And in 2018, Qualtrics was sold for $8 billion, which is the highest price ever paid for the acquisition of a company that had just gone from private to being acquired. Now, a few words about getting admitted into the College of Engineering. You need to apply to the U in the fall of your senior year and indicate your engineering major preference. You'll receive a letter of admission from the U when you're admitted, and it will indicate whether you were directly admitted to the college or whether you were admitted as a pre-engineering student. I list here the 3 ways that you can get direct admission. It's dependent on your GPA and ACT scores, or if you don't have ACT scores, GPA, and you must have taken calculus and have a very strong high school science background. When you get your admission letter, then you need to accept the admission. There's a date by which you need to pay a deposit. Then you meet with an advisor in the college, and whether you're direct admitted or admitted as a pre-engineering student, the object is to get you admitted as a major student in your discipline of choice. And that usually happens by at least the end of your freshman year. What we're really looking for to determine whether you come in as a pre-engineer or as a directly admitted student is whether you're prepared to take the engineering curriculum. And that is highly dependent on your math readiness. So you can demonstrate math readiness by getting a 95 on the college Accuplacer test, or a 28 on the math portion of the ACT, or a 630 on the SAT math, or by getting a 3 on the AP Calculus A, B, or BC test. Or you can take the university classes, Math 1050 and 1060. We'd like to recommend, if you're still in high school and thinking about what courses to take, please take physics, chemistry, and biology in high school. We strongly recommend that you take AP English and AP for other gen ed requirements. And if it's available in your high school, take the high school engineering course that was developed here at the University of Utah. Now, some of you will have questions about taking leave. If you're planning to be away for a couple of years, we still recommend that you apply in your senior year, get your admissions, get your scholarships, and then apply for a deferment. If you're admitted with a deferred start, your ACT and AP scores will not expire, your scholarships will be held, and it'll be very easy to be readmitted. One thing we strongly recommend if you are going to be away for a couple of years is that when you come back, you take a math refresher course, which is offered here at the university. Your math placement will not be compromised if you do that, and you'll be able to move smoothly back into the engineering program. I should mention we have an excellent engineering math sequence here at the University of Utah. It was even written up in a magazine of the American Society of Engineering Education as a model for other universities. You may also be interested in how you're going to fund your studies. There are lots of options. We have many scholarships available at the university, at the state. Other organizations offer scholarships. We highly recommend that you apply for those. In the College of Engineering, we give out about 455 scholarships and fellowships amounting to $1.7 million a year. As an engineering student, you can also get internships, and we recommend that you do that. Engineering interns are paid well. You can make enough money in the summer to offset a lot of the cost of your education. Some students also work part-time during the year, and that is a good option as long as you keep the number of hours you work down to about 10 hours a week. There are also federal and state government grants, and we're happy to help you get more information on those, and student loans are available. One thing that I wanted to tell you, even at this early stage as you think about your education, is plan to be a full-time engineering student. Engineering is a challenging enough discipline that you need to be able to really focus on it. So you're much better off to be a full-time student and get graduated in 4 years and then start getting paid well than to go part-time with a much lower salary and drag your education out over many years. We have a presentation we've put together that we'll show you in your freshman seminar courses that will have a lot more detail about how to fund your studies. We share probably your aversion to taking on debt, but let me say that in engineering, it makes great sense, even if you have to take out some student loans, to do that and get graduated quickly, because you will get a great job and you'll be able to pay those student loans off quickly. In summary, there are great opportunities in engineering and computer science. It's a challenging curriculum. It's built on science and math with creativity. You get to create things that never would be without your involvement. There are financial rewards when you get your degree. I talk to engineers all the time who love their jobs, and I've talked to many people who started in engineering and switched to something else who really wish that they'd stayed with engineering for the job satisfaction. There are opportunities in engineering when the economy is strong. Even when it's weak, it's still so much better in engineering than most other areas. And as I mentioned, you will be in high demand. We've done surveys of our graduates, and there are so many jobs in Utah that anyone who wants to stay here can get a great job in the state. Of course, there are also wonderful jobs in other states. More importantly, with the education that you'll get in engineering or computer science, you'll be able to help solve the real problems that we have in the world today and contribute in all of these areas. So we hope that you'll consider coming to the U for your engineering education. We have world-class faculty, facilities, equipment, and a reputation that will make your degree very valuable. With that, I'll stop sharing. And if there are any questions, April, that you've seen in the chat that you'd like to pass on to me,
yeah,
I'm happy to answer one or two.
Let's see. I think we got most of them. It was a very active chat. So does anybody have any last minute questions? Let's see. Are there any programs to include are there any programs to include policy with an engineering degree?
Policy. We actually have several faculty members who are focused on policy. For example, in ECE, there's a faculty member whose research is related to electrical energy distribution and policies related to that. So you will see some courses throughout the college. For example, in civil and environmental engineering, there will be courses on the environment that have a lot of discussion about policy, and to some extent that'll be true throughout the college. I should mention at the master's level, we have joint degrees between engineering and business. So there are a number of opportunities, and there's also some flexibility in elective courses so that a person could take a course in another college, another department that was focused on policy and use that as part of your general ed or technical electives. Okay, I think in the interest of time, I better turn the time over to April, who will say a few words about what you're going to do next. Again, it's been great to visit with you. If you have any questions for me, my email is brown@utah.edu, and I'd be happy to answer your questions.